I have a triangle and I know the three side lengths. Okay, I know the side lengths of all three sides of a triangle. What can I name it now? What can I name it if I know all three sides? There's three different names you can have. First name is if all of those three sides are the same length. All right, yep, Connor? Equilateral, there you go. There's our first one. So if all three sides are the same length, we say it's equilateral. And you guys can see the hash marks there, which a reminder means that they're all the same length with the hash marks. All right, I look at it. Two of the side lengths are the same, but the third one is different. If two are the same, third one is different. That's an. Anybody want to grace some knowledge here? Cadence? Isosceles. Perfect. That's isosceles. So we have equilateral if all three are the same. Isosceles if two are the same. What if none of them, all three are different? Anybody know that one? All three sides are not the same length. They're all different lengths. Okay? Scalene. Perfect. Yep, that's called scalene. All right, and that's if I know the sides. Right? Sometimes, though, I don't know the sides. I won't know the side lengths. Instead, I'll know the angle measurements. I'll know the angle measurements. First, anybody, all three angles in a triangle, no matter what type it is, all add up to 180 degrees. All right, 180 degrees. All three of them add up to 180. What if all three are exactly the same? All three are exactly the same. Meaning, anybody know what they have to be then if they all add up to 180 and they're all the same? All three angles have to be how many degrees then? Got to be what, Warren? 60 each, yep. So if they all come out to be 60, all the same, yes, technically we could call it equilateral because that means the sides would be the same. But if all angles are 60, we can call it, this is a fun word to say, equiangular. Equiangular, if all three are the same or 60 degrees. All right, next up, you'll see the next triangle. I only put one angle in because that's all I need. See that angle measure? 105, bigger than 90. Bigger than 90. So if one angle is bigger than 90, first of all, what is an angle bigger than 90 called? Because that's what you call the triangle. Warren? Scalene. Oh, scalene is if I know the side lengths. I don't know anything about the side length, so I can't call it scalene, isosceles, or equilateral. All I know is it's got a 105-degree angle, one angle bigger than 90. Jack? Obtuse. Obtuse, yes. This is an obtuse triangle. And all you need is one, because it's impossible to have two angles bigger than 90 in a triangle, because you guys told me where they all have to add up to. Okay, so you can't have two angles bigger than 90. If they all add up to 180, that's impossible. So all you need is the one angle bigger than 90. It's called obtuse. We've seen this a couple times already this year. The box tells me what type of triangle now. That is a right triangle. Okay, that is a right triangle. No questions asked. I don't care what the other two angles are. If I see the right angle symbol, it's a right triangle. And then finally, I have 70, 30. We could find the other angle if you want, but as long as two angles are less than 90. Anybody? What's the angle? Obtuse was when it was bigger than 90. When it was less than 90, we have, what do you got?
Acute.
Acute, yep. So this is going to be an acute triangle. That's only if I know the angle. So everyone good. A lot of different names for the triangles, depending on if I know the sides or the angles. All right, let's do some calculations now and throw in a little geometry, some past vocab. Right off the bat, I tell you, M is the midpoint of JL. All right, first question of the day for somebody. If M is the midpoint of JL, give me two segments that are congruent up here then. All right, M is the midpoint of JL. Give me two segments that are congruent because they're not marked on my diagram up here. Ariel? Good job. JM and ML have to be congruent, so you can mark that on your die. Oh, yeah, I'll look at that. JM and ML. Congruent. Good. What am I asking for? What type of classified JKM? Hey, I got a couple triangles rolling in this diagram. Figure out where JKM is. We name a triangle by its three vertices. Everyone see triangle JKM? Maybe you want to highlight it in pencil or pen right now. I'll do it in yellow. JKM. I want to know what type of triangle that is right there. Well, before you guys tell me, I need to know what the side lengths are. This isn't an angle problem because I don't know squat about the angles. So I need to figure out what all three sides of JKM are. I know one side is 0.75. Can you guys help me find the other two sides? So I can tell you if it's equilateral, isosceles, or scalene here. Okay, can you help me find the other two sides here? Let's start with JM. Let's start with side JM. I don't want to know the length. Explain to us how you're going to find the length of JM now. How do you find the length of JM? Twos here. I'll get to you there in a second. There we go. Cadence. How do you find JM?
Divide 1.5 by 2.
Good, because it's the midpoint, right? We were told M's the midpoint, cuts it into two equal parts. 1.5 cut in half. What do you got there, Cadence, when you have it? 0.75. Good. So that's going to be 0.75 for JM. And the only other side I need that's missing is KM before I could tell you what type of triangle it is. And I don't think we have to do any calculations here. I just look at the markings. How about KM? Length of KM? 6 as me. How long is KM? What do you have? I'm sorry, I didn't hear you. 0.75 because look, everyone see the hash marks, right? KM and JM were both congruent to each other. So 0.75. All right, now everyone look at the three side lengths. You tell me what type of triangle it is now. I got 0.75 for all three sides. We refer to this as what? Hey, this is by its sides. Don't hey, I shouldn't get acute. I shouldn't get obtuse, right? You should be basing it off its side lengths now. There's only three choices off its side lengths. Don't tell me any. We don't know anything about the angles, so don't use anything down here. Based off its side lengths, what type of triangle, Jack? Equilateral. Done. All right, so I'm going to put triangle because I want you guys into the notation. Triangle JKM is equilateral. Questions on how we got there? Got to know something about all three sides before you determine the name. Ready for 2? Okay, on 2. I'm going to tell you it's isosceles. I'm telling you where the two congruent sides are by the hash marks. I want you to find all three side lengths now. All three side lengths. I did this on purpose. Notice, hey, everyone see how I have a label on all three sides? That doesn't mean you need all three sides in your equation. Just because I've labeled all three sides doesn't mean when you set up an equation to solve for x, you need to use all three sides, because that's not the case here. I don't need the 9x minus 1. I need the two sides that are congruent. You got something I can set up to solve for x now. Got something I can solve for x here. Okay, Sloan, you want it? You got it.
4x plus 1
Yep.
equals 5x minus 0.5.
Perfect. That's all I need. I don't need to get the 9x minus 1. It has nothing to do with it. Also, this really gets me fired up. Kids will add up all three sides and set them equal to 180 degrees. Degrees. Sides don't add up to 180, kids. What adds up to 180? Angles. These are sides. Get that business out of here. All right? Sides don't add to 180. It's the angles. Are we all good? Sorry for some of you that wrote that. Now I'm getting fired up. It won't happen again, I bet. All right? Sides don't add to 180. The angles do. All right, go ahead. Solve for x. Don't feel the need to use all three sides in the equation. It's probably not going to happen. When you figure out what x is, let us know. Go in there. Connor? 1.5. That's what I got as well. That doesn't make us a winner, though. That's not what I wanted in the problem. I wanted the side lengths. So you're going to take Connor's 1.5. You're going to go back in, substitute it in to find AC, BC, and AB. And in your mind, you're saying to yourself, I know I did this problem right if two of the sides come out to be the same length because this darn thing's isosceles. When you have those side lengths, let us know. If you don't, take your time, though. I want to hear from you, Evelyn, when you're ready. Good talk. I'll see you tomorrow. You owe me one. Sloan, back her up now.
Wait, all the side lengths?
Darn right I want all of them.
AC is 7. BC is 7.
Oh, better be. Better be this. I can't have two different answers for AC and BC. It said it was isosceles with those sides being the congruent sides. And how about AB? Sorry.
12.5.
12 and a half. Good job. All right. Questions? You do not need all three sides sometimes. And by the way, they don't equal 180, right? The angles equal 180. That's tomorrow's topic anyway. All right. Final one here. I told you it was going to be a short day. Give you the guys 45 seconds here to graph triangle DEF. And then we'll discuss how in the world are we going to figure out what type of triangle that is. Nothing fancy. You don't need a straight edge. You just connect the darn points. Nothing fancy. All right. Classify this triangle by its side. So at the end of this problem, somebody's going to tell me this is equilateral, this is isosceles, this is scalene. Because those are my only three options based on its sides. But to do that, I need to know how long those sides are. Right? To say if it's isosceles, equilateral, or scalene, we got to figure out how long those sides are. Oh boy! I believe we have something available to us that will find how long those sides are. It's been a while since we used it, but we're coming back to use it right now. What have we talked about this year, specifically Unit 1, that will find the length of DE, DF, and FE? We have something available to us. We just got to rehash it. Sloan?
Pythagorean theorem.
We could use Pythagorean theorem, or let me just review that, because that is going to be one option. If you wanted, let's say, for example, DF. If you wanted to find DF, you make a right triangle out of it, find the length, count the length of those two sides, and do a squared plus b squared equals c squared. And the answer to C will be the length. Yes? And then anybody remember the other version that we could do Pythag or... Jane?
Distance formula.
Oh, yes! Coming back. The distance formula. Big square root underneath was x2 minus x1 squared plus y2 minus y1 squared. Yes. So you pick your poison right now because you have to do this for 3, not 1, 2, 3, all 3 sides right now. All right, so do you want to use Pythag? Use Pythag. If you want to use the distance formula, use the distance formula. Leave all your answers in the simplest radical form that the calculator gives you. No decimals, please. No decimals. So right now, I'm going to give you plenty of time since we have it. Find the length of DF, find the length of DE, and find the length of FE. However you prefer, distance or Pythagorean theorem. But everyone, leave your answer in simplest radical form that the calculator gives you. Please, no decimals. I'll call on 3 people here in a minute to get your distances. Then we'll determine what type of triangle it is. Be prepared to use this tonight. There's a reason why we're going over this problem in the notes. You're gonna have to probably do this tonight. You don't need to graph it though. You don't need to graph it. If it helps to graph because you want to do Pythagorean theorem, then go ahead and graph it. But I'm not requiring you to graph this problem tonight. You don't want to. All right, ready to roll here. See what we got for our distances. First person up can start with any side you like. Give me any distance that you like. All right, start it off there. Noah, whatever distance you want.
DF
Yep.
equals 3 and square, and then inside square root of 5.
3 square root of 5 is the length of DF. Perfect. Yes, 3 square root of 5, whether you did Pythag or distance formula. Good job. All right, any of the other two here? Ones, let's try that again. There we go. We'll go a little deeper there. Nope. We'll try that again. And Nick, what do you want, DE or FE? DE, go ahead. DE? Square root of 113. Yes, that could not be broken down. That's why your calculator gave it to you like that. Square root of 113. And then finally, how about FE from somebody? FE 25. Noah, back to you.
2 and square root of 26.
2 square root of 26. All right, so there are my 3 side lengths. Okay, there are my correct 3 side lengths. Any of them the same? No, all 3 sides are different lengths. So we are going to finish this up by saying triangle DEF is all 3 sides are different lengths. That makes this triangle what type, Charlotte? Scalene. Everyone good? Why? All 3 sides are different. Not acute, not right, not obtuse. I don't know anything about that's for angles. That's for angles. Questions? Okay, you know where to go now. It's not in the packet tonight, so you guys know where to go.